Thank you very much for having me here. Thanks to all the organizers for this conference, and for you and online to be here for the last talk. I know it's late on Friday, and you want to go home soon, but please go to Boss and so on and so forth, and to Sprint tomorrow, of course. So hi, I'm Matthias. I've been part of the Jupyter team for about 10 years, so since before it was called Jupyter. And one of my little things I want to fix is documentation. I've been interacting a lot with novices and people who have never programmed or have done Python before, and I find that they struggle a lot to find the right documentation. And I am happy to be able to work on that thanks to the Chan Zuckerberg initiative, EOSS initiative that funded this project for 2 years via NumFocus and Quantsite Labs. So the main goal of Papyri, and I will mostly do demo and fail because I've pushed code 5 minutes ago, was to provide rich, unified documentation experience from within Jupyter, with plots, navigations, if possible, narrative docs, because you know that right now, mostly when you use ? You only have API docs. And there may be a bunch of other things that we can do. Come talk to me later if you want to discuss that. And in particular, have better accessibility, tutorials, and a bunch of stuff. And so I'm going to start with a demo, just to fail early in the talks. Fail early is always good in programming. And so here I have a Jupyter lab with a really complicated notebook. We don't really care about what the notebook is doing. We'll care about the documentation. But I want you to imagine the experience of a newcomers who want to figure out what this DPSS function is, run that, and have a bunch of source code and get the underdoc printing to them. I think it's quite hostile to new users. You don't have syntax highlighting. Here you get directives. If you are, and as a maintainers, you tend to push back on putting directives in docstring because users will see them. But you want to put more because it's going to make the online docs better. And you have the code, which, if you copy paste, you have to remove the prompt, and you don't see the plot. Well, the full point of this chunk of code here is to show a plot, and etc. So I've been trying to fix that, and so I'm going to turn Papyri on and ask the same thing. And now I have a side panel, which is a documentation browser that shows me the same docs with the parameters. You can even have text reflow, which is not much, but already a great improvement. And you have links here. So if I want to go to interpolation 1D, I can click on there and go to interpolation 1D. I have my examples that are syntax highlighted. And if I wonder what something is, I can hover and I can likely go see what this is. So for example, here I have my plots. And for example, I'm wondering what is eigenval. I'm going to click on eigenval, and now I know that eigenval was actually an NG array, and directly I have all this information about NG array. But I can also go, for example, here I have bookmarks. So the breadcrumb, don't worry, they just don't work because I don't know how to write TypeScript. You can go, for example, go see NumPy dev index, and you do have at the end, you will have the talk tree, so you can navigate the talk table of content. And so now that means that users will directly have access to everything directly from within Jupyter. One thing which is quite difficult, though, is to move across libraries or find new libraries, because usually when you publish documentation, your dependencies can link to you, but you don't know your dependencies when you build your doc. So it's, for example, really hard when you work with NumPy to figure out that Dask exists and does distributed computing, for example, because you need to know about Dask before. What Papyri does, the way it works, is it's aware of the graph of documentation. And so when you build documentation for dependencies, it can update the dependency pages to show reference back to the dependencies documentation. So for example, here I open the NumPy InSum documentation. And at the bottom of NumPy InSum documentation, you have everything in the documentation that I've currently built that links to NumPy InSum. So for example, here, I know that there is Dask InSum that allow you to do distributed InSum, and you should be able to go to the examples and find arrange, which return an array, and so those things have a lot of back references. That is not something I have solved yet. I didn't have time to write something to trim that to a better UI. But that's roughly the ideas of what I want to bring to Jupyter. I want users to not have to leave Jupyter, and when they ask for documentation, get something which is as good as the HTML documentation that you get online, with even more power, because the data is not HTML, but it's structured. So let's go down a tiny bit into how that works internally. So in case the demo did not work, all screenshots, you don't care. So why did I do that? To rehearse a bit. When you have online documentation, the documentation might not reflect the current version of the installed library. You have to have your users know which version they have and go see that, because users don't update. It's hard for a hard practitioner to find official documentations. I've often seen in classroom someone trying to play with, say, SciPy and pandas, and they find some nice documentation on the SciPy website, and then they go on the pandas website to find the documentation after Googling, but they say, oh no, it's not the right one, it's not green. And so the fact that you have different appearance for different documentation websites is something which is hard for novices, because they don't make the distinction between the language and the libraries, and they don't have these concepts yet that they need to Google for a specific library. And there is a no index, no follow problem, which is when you publish a new version of the docs, like recently Matplotlib, but for a long time it was pandas. You Google and you came across the wrong version, and you have to patch the HTML to show a big warning that nobody reads at the top of your docs. If it was easy to automatically show to the users the right version of the docs, would mean that this problem would never be there. And you have a limited cross-library integration. You have intern things, but it's I think we can do better. But of course, you have nice HTML, which looks great. So that's really good. And the current Jupyter documentation, you always get the current version because it pulls from the docstring. It's directly accessible. You don't have to switch to something else. But maintainers are stuck with simple syntax. I think I've heard a lot of people who want to switch to Markdown for documentation in docstring, but the problem is that they don't want to show a different syntax between libraries to not confuse the user. And so if we could display something which is not the raw docstring, then that would allow maintainers to choose which syntax they use for their docstrings. So my goal is to get the both of both worlds. And so right now, when you build documentation, NumPy, Matplotlib, SciPy, you use something like Sphinx, mkdocs to directly do HTML that you publish on numpy.org. You do the same with Matplotlib, with SciPy. You may use intersphinx, for example, that will link to the version of like from SciPy to NumPy. But if, for example, the NumPy doc moves, then all the links of SciPy that links to NumPy are broken, or it's the wrong version, or things like that. It's computationally intensive because you need to run all the example, and each library, each website sort of live on a silo. And when you update a Sphinx plugin, for example, there is a new version, you need to rebuild the world. So can we also try to fix that? And so what I'm suggesting, instead of building independently, instead of going directly to the final HTML, you stop to an intermediate representation that you publish that have enough information, enough semantic information to be able to later do the documentation. And the user or you, and if you're an organization, you install all of that together on your system. And then the IDE you use, like here, Jupyter Lab, as I showed, can decide to pull from this representation with the right version, with the right crosslinks, and show that to the user. That also, in particular, lets the user choose their rendering engine. If they want to decide to use a rendering engine that don't show type annotations, they don't show type annotation. If they prefer to use dark background, they use dark background. If they don't like the PyData Sphinx themes, they don't use the PyData Sphinx themes. Or you can do things like render to terminal, for example, for those of you who are who, like me, really like only pure text monospace and could live great in the 80s. So Papari trade-off. You have better documentation for end users and current object question mark. You have more flexibility for end users and more unified, coherent documentation. And there is separation of concern between building and rendering. So it means that you, as a maintainer, if you have a small library, you can build with Papari. If it works, you don't have to worry about how it looks like because someone else is going to write a renderer. So it's basically splits the problem in half, and you can focus on your area of expertise. The cons is that you need to have something uniform, so there is less flexibility for maintainers to change appearance. So it's not going to replace things and so on and so forth. Like for big website, if you want to have books like Jupyter Books, it's not going to replace that. There is currently way fewer plugins that match your documentation engine because it's really new. And currently, all the installation and publishing is not done, so that needs some work. And library needs to be opt-in. You can build for someone else's library, but it would be much better if each library in their CI would build the Papyri intermediate docs and upload them somewhere. And so as a demo of that, I'm not a TypeScript person. I prefer static HTML. So I wrote a Flask server that pulls from the same documentation and give you something that looks like a website. And so now you can navigate the documentation. Like you can look at the NumPy documentation. You can go see the narrative documentation on NumPy. You see that some of the directives have not been implemented yet. You can come back. You can go see SciPy. And now you can be smart. You can say, hey, find all the pages that have images and show them to me. So I have basically Sphinx Gallery for free, automatically across all the libraries everywhere. I can also do that with math. Find me all the math equations in SciPy. So this is all the math equations in SciPy. You could imagine doing it for all the deprecation warning. And as I might say later, if you're crazy, you can, because documentation is semantic, take the documentation of NumPy 127 when it's published and backport all the deprecation to NumPy 119 so that people that use NumPy 119 know that things will be deprecated in the future. You can also do some crazy visualization. Like, for example, if I go into NumPy array, you have all the forward and backward references. So you can say, hey, I'm going to use D3GS to show the local neighborhood of what points to what. And so each color is a different library. And so you see that all of that is something that points to NumPy. And so maybe if someone knows visualization and JavaScript, they can make something that allow you to find interesting information in that. I don't know how to do it. There are network rigs folks there. I'm waiting for you during the sprints. And at the same time, I also had, a terminal renderer. I think white background is better than black background for demos, but the color might not be the best. Can I zoom in? Yes, of course. Let me just finish typing my commands. So I have an Arwid browser. I would love for someone to rewrite it using Will McGugan textual because Arwid crashes. And so now I have documentation of Papyri itself here, and I can navigate. Like I want to go see SciPy signal Bartan, I can go see the documentation. And something that grinds my gears when I use IPython is I cannot use really narrow windows because it doesn't reflow properly, and that does reflow properly, and have syntax highlighting for examples, and even navigation in examples. I should be able to go see matplotlib.plt so I can navigate. And I was able to write this renderer without ever having to rebuild the NumPy documentation or the SciPy documentation or the Dask documentation. So that's the end of demo 2. That didn't crash either, which is great. Because most of the time there is something where I have the type wrong. And so you basically have maintainers don't need to worry about final appearance. You just build the documentation. If you have UI improvement in the renderer, you get it for free. User can choose a renderer if they want. Maybe you can inject content. Don't show type annotation. Let your imagination go wild. You could, for example, have your own packages that publish just examples and inline them in the docs, and so on and so forth. I want to show a tiny bit how to build the documentation. It's not much faster than Sphinx, which is what a lot of people ask, because most of the time Sphinx takes is when you want to execute examples and do a lot of the cross-linking. You can't be much faster than that. But Ryan Abernathy, which maybe is around, asked me if I could build the documentation for Xarray. So here, oh no, not cat. So here is the base config. It's a TOML file. Try not to do .py execution because it's hard to auto-update after. I'm going to generate the doc, and here, for the sake of time, I'm not going to do type inference of all the example. I'm not going to execute. And so it's going to fail on some examples. But basically, it looks like Sphinx. You have a progress bar. It tells you how much time there is remaining and how many objects it found. Here, 2,300. And so now you have this documentation bundle at this location that you publish, that you get with wget. I mean, you need to implement all of that so that it's easier for the end user. And then you install it. And because it's a graph database, it's smart and will rebuild only the HTML page that have new back reference. So it's relatively fast. That's it. Rebuilding all of this, we built all of SciPy, NumPy, Dask, distributed, like everything which was there has been rebuilt in a couple of seconds because it was smart enough. And so now if you go to, for example, Pandas documentation, you do now have back reference to Xarray. And same thing if you go to NumPy random, that I refresh the page, you now should have back reference to Xarray. So you can do really smart updates of your pages. You don't have to rebuild the world to have a coherent documentation experience. How much time? Okay, I'm slightly ahead of time. So next step and future and sprints. So short term, I would like to automatically build and for an alpha version for many of the core libraries to at least find the 8 cases, find the difference in syntax. I already find a number of cases where the syntax that I use with the RST parser I use is not understood. Polish the Jupyter Lab extension to actually work, because here I had rehearsed exactly what to click on for it not to crash, because I don't know TypeScript. So have a really nice breadcrumb, have bookmarks, have push and pop navigation to come back, have search, because you have a SQLite database in the back if you want to actually search for your objects, and full text indexing. Midterm, you need to stabilize intermediate documentation bundle format, because if this is not standardized, then you have to rebuild everything every time. It's worthless. And so I'm hoping to do that in the next 6 months or so, once all the edge cases have been found, and after had new versions, do a version 1 and then version 2 in 2 years. Have some accessibility UI UX study for the documentation browser, because one of the things you can do with that is update the renderer to be accessible. Colors, or hide and show things, etc. And in the long term, things like supporting Markdown, especially for doc strings. You can think about localizing the docs, because now you have something which is semantic. So you could probably push that to something like Transifex or those websites that allow you to translate and have translation. If you're crazy, you could also imagine changing the datasets so that's the same examples in things like scikit-learn or scikit-image show either a GWST telescope image or a brain, depending on the scientist that is at the end, because that's depending on your field, you see the exam same code with 2 different examples you understand or not. For example, maybe, if that works great, have that understood by Conda, so that when you Conda install or pip install a library, the documentation automatically comes with it, so that you don't have to have a separate step for the user, because right now it's a separate step. Crazy idea I already talked about, future deprecation. The intermediate representation is semantic, so you could pull documentation from the future. Sort of. Content injection in businesses and organization. Like if you deploy a Jupyter hub on a cluster and are using Dask, inject at the top of the doc string, here are the instructions to use Dask on our Jupyter hub. Or some advice, don't use this function, or if you have questions, here is how to open a ticket with IT. Telemetry as well, figuring out which page are seen the most by users. Opt-in, of course, you don't want to track users by default. Even for yourself, knowing which function you keep looking at, or if you teach which function your students look at. And I would love to create allthedoc.org, where basically you upload all of the doc bundles, and as a user, if you want to browse the documentation online, you upload a requirement docs.txt, and all the cross-references are with respect to your version of the library you uploaded. Okay, and so how can you help? Sprints, come talk to me and help me get things out of my head into issues. Test it and complain. You can go to Papyri and read the instruction and try to make it to work and what is unclear. Tell me which library you like support for, either as a maintainer or as a user, so that I can figure out which 10 libraries to focus the most on so that we reach the most user. And feature requests. If you had a magic wand, what would you do in documentation? Try to think outside the box, and subscribe to issue 1 for news and spread the word. And also, if you know TypeScript, because right now my main problem is TypeScript because I don't know the syntax and I'm not a front-end person. I prefer Terminal from the 80s. With that, I'm going to thank you and take some time to take questions. I will make the more demo if you request it. And come find me into the sprints, and I have 11 stickers left if you like it and you want to be the first to have stickers. Thank you.
Thank you for a great talk. Can I take a question from the audience? Anybody have a question over here? If not, we'll
stand up and come, see if you have questions.
We'll go to the virtual questions first.
We have like a couple, so do you want me to alternate or just read all of them? Okay. Is there full text search functionality for installed documentation?
Right now, no. What I've shown here use SQLite because I'm mostly focusing on users' machine. SQLite does support full text indexing, but you would have to do some extra things. But because the bundles are semantic, you can build a full text search on top of that. I would love to, I just don't know how to and don't have the time.
All right, I think I saw a hand. You had a question?
Yeah, as an X-ray dev, then that looks awesome, and thank you. How do we get these benefits to our users ASAP without breaking the documentation that we already have and people rely on?
So that does not require you to change your documentation at all. If there is corner case, like for example, I find corner case in NumPy where the directive was ... space, the name of the directive space ... which is technically not valid syntax for Sphinx. It was, I think there was 2 out of 2,500 cases, like 2,500 thing. I was like, please NumPy, can you remove this space? And they were like, yes, that's not a problem. And that prevented me from having to write 100 lines of code. And so that helped me. That also helps because documentation become more standard. So having 2 competing implementation of RST parsing allow you to find edge cases. But right now, you've seen the documentation of Xarray does work. I haven't built the narrative documentation of Xarray. Come sit down with me during sprints and try to make it work on your machine. If you know about packaging to publish documentation, we can talk as well.
Well, we have another online question, and then I think Gwen will bring it around to in-person people. So will telemetry be too controversial due to possible privacy violation and so on?
Do what? Privacy violation of IP?
Will telemetry be too controversial due to possible privacy violations?
So I'm not going to implement telemetry. I'm suggesting that if you have an online deployment, you as your organization, and want to track what your users are doing and which documentations are looking at, this can help you implement telemetry. Because you just have to hook into the renderer, or actually you just need to hook into the database and ask the database which pages have been requested. And so now you have a count. I'm not going to do that by default in this implementation.
So do you actually have plans to do stuff with narrative documentation with this, or is it just
so do I have plans? So not to write any narrative documentation. Well, yes, but narrative documentation for my project, for Papyri itself. But right now, if you go to the Flask server, because I haven't implemented all of that in the Jupyter extension, and you go to narratives here, you have the full narrative NumPy documentation, which is mostly rendered except just this page, of course. You have some things that are not implemented, some directives that are not implemented, but you have the full NumPy narrative docs here, except auto summary. So this is there. You can browse it. There are plenty of bugs, plenty of syntax errors, plenty of edge cases, plenty of issues to fix during the sprints.
So when this is fully fleshed out, would there be any reason to use Sphinx?
That's yes, but not for all projects. Like you will never replace Sphinx because Sphinx is completely generic and you can modify Sphinx to do whatever you want. So if you want to publish a book, like I wrote my PhD using Sphinx, I will never write my PhD using that because that's made for documentation. For really big projects that also have non-Python, you could extend that to non-Python thing. That makes less sense. Like for example, PyTorch, which has like really nice examples, they probably want to still use Sphinx, but can use that as a subset for API documentation and a number of tutorials and examples.
Okay, online question from me. Why didn't you use Papyrus in your logo?
What? Papyrus? I mean, what, this?
The Papyrus font. She was curious if you considered the Papyrus font for your logo.
You can write a renderer for Papyri that shows the Papyri logo with the Papyrus font, or the Comic Sans one if you want.
Have you talked with the Sphinx developers or Read the Docs or other existing doc systems to see where work might be collaborated on? And
yes, so I've talked with Eric Holscher at Read the Doc, and he has interest in that. A lot of the time spent in CI, in computation and by developer is to reconfigure Read the Doc, to rebuild what most projects already do in CI to verify the docs works well. So we're basically using the computation twice. And one of the ideas when I showed all the docs.org, I don't remember here, it's basically a play on word on Read the Doc where I want to read the doc, but not on different subdomains, where you as your project build the intermediate documentation in your CI, have a token, upload that to Read the Doc, and all the doc renders it for you. And it would make some of the hacks, good hacks that Read the Doc is doing, like for example, to inject the documentation switcher native to the rendering, because you don't have to patch the HTML anymore. You can just re-render the page when you decide to re-render the page, and when the documentation is old because it is a new version, you just re-render with no index, no follow, and Google does not index it anymore.
Okay, we still have some more time for questions. I think there was a follow-up question here. Is anybody else?
And after I'm around, so you can come talk to me during the break.
Right.
Sorry if I missed this in the talk, but you're building these from like RST files, right? So what happens if you have a library where the documentation is in the form of many Jupyter notebooks already? Like I think like Bokeh might do that, or there are some libraries that have that.
So right now, I decided to only try to parse RST because I only, have 7 days per week. I'm not like other people who can, like 10 times developers. So I focused on that because that's what most of the core of the Python library do. The code base is not really pluggable yet. It's assumed it's RST, but there is nothing that prevents you from creating something that works with Markdown. And you can generate doc bundles with your own tooling if you want. Like if you want to start writing Ruby that generates those intermediate files for your library, that's fine. It's completely fine. And you can also write something in Rust that takes those intermediate files and reads them. If you're interested in that, I would encourage you to go see the proceeding and the comparison in particular between that things and compilers. Like if you look at something like LLVM, WASM, the goal is to take different producers, different consumers, regardless of the language. Here the language is RST or Markdown, and different compilers, which would be Papyri or Papyrus, if Madison want to do that. And they work together because they have this protocol. And a lot of what is interesting here is not the implementation I wrote, but the specification of those Bogdan file and the protocols of how you talk between multiple bundles.